Hello, now we are going to look at multiplying fractions. And as so often in maths, we are going to start with what we already know well and we're going to build on it. So we have 2 of 3, or 2 multiplied by 3. 3. Let's try that again. 3. So we have 2 multiplied by 3. We already know the answer is going to be 6. Now, we know that 2 is really 2 all over 1, and 3 is really 3 all over 1, and we end up with 6 all over 1. So what we are used to thinking of for multiplying our whole numbers, we have 2 multiplied by 3, and if we look at it as fractions, we just multiplied numerator by numerator, and we got our 6. But what happened with the denominators? Well, in practice, what we actually did was multiplied the numerator by the numerator, as we already knew, 2 by 3. And the denominators, we multiplied together as well. We multiplied 1 by 1 is 1. So we ended up with 6 all over 1, which we call 6. So this gives us our rule. This is an example with whole numbers of our rule for multiplying fractions. We multiply the top number by the top number and the bottom number by the bottom number. And in a hidden way, we've been doing that for years, because we know with whole numbers that we just multiply them together. We also know that whole numbers have a denominator of 1. So in practice, we've been doing fraction multiply without thinking about it for a very long time, just with denominator 1. But again, we multiply top number by top number, divided by bottom number by bottom number. That's all we have to do for fraction multiply. If we think about the meaning of this multiply, if we think back to what we mean by multiply in general for whole numbers, if we have 2 of 3, that means we've got 2 of this thing. So we have 2 groups of 3 units. So in this picture, a unit is each one of the boxes. So 1 unit, 1 unit, 1 unit, 1 unit, 1 unit, 1 unit. So we have 1, 2, 3, 4, 5, 6 units altogether when we have 2 groups of 3 units. That's what we mean by 2 of 3, or 2 multiplied by 3. Now, can we extend this understanding that we already have for whole numbers to when we have to deal with fractions? Well, if we have 2 of 3/4, in this picture, each one of the bigger boxes, each one of the bigger squares in this case, is going to be 1 unit. So different to the last time. Each one of these overall boxes is 1 unit. And I've broken them up into 4. So if we do this visually first, we have 3/4 of, or 2 of 3/4. Well, what does 3/4 look like? 3/4 would be 3 of our 4 boxes in our unit colored in. So that's 3/4 of one of the units, and that's 3/4 of the other unit. And we have 2 of these. So we would have 1, 2, 3, 4, 5, 6. I expect to have 6 quarters if I have 2 of 3/4. I have twice as many. Just like I had 2 groups of 3 would give me 6. I had twice as many as I had when I had 3. So if we write that out now, I'm expecting my answer to end up being 6 over 4. I'm expecting it to be that, and let's see if that's what we get. So we know that 2 is really 2 over 1, because it's a whole number. And of, we mean we have 2 of these things, so we're going to have twice as many. We're multiplying. We've looked at our rule now, so let's do this out by rule. We multiplied top number by top number, and bottom number by bottom number, numerator by numerator, denominator by denominator. We have 2 by 3 all over 1 by 4. So we end up with 6 all over 4, as we might have expected based on our picture. So we can see how our rule is giving us the same answer as we got from drawing out our pictures. Now we can simplify this fraction, and whenever we can, we should always simplify a fraction. So we can say we have a common factor of 2 top and bottom. So our final answer we would take out the common factor of 2. So we'd have 3 by 2 all over 2 by 2, which is 3 all over 2 times 2 all over 2. 2 all over 2 is 1. That's why we took out our common factor, so we'd end up multiplying by 1. So we have 3 all over 2 multiplied by 1 is 3 all over 2. Or you would be able to, taking our other example here, you would be able to divide above and below by 2. Another way of showing the same thing is to divide above and below by 2, and you'd end up with 3 over 2. And we need to be able to understand both methods, because this one is quick and this one tells us why it is we're doing and how we're doing it. So we're going to write out our rule for multiplying our fractions. So we have multiplying fractions. All we have to do is numerator by numerator, denominator by denominator. So top by top, bottom by bottom. Top by top, bottom by bottom. Or numerator by numerator, denominator by denominator. And that's all we have to do, and then we simplify if we can. So let's do another example in terms of our visuals. We have a half of 6/8. So we're going to do this visually first. What does 6/8 look like? In this case, 1 unit is this bar here, and 6/8 is going to be, I'm going to color this in quite deliberately so that I can break it up conveniently. So there are lots of different ways that you could shade in 6/8. So if I wanted to have half of 6/8, well, this is 6/8. If I only wanted half of them, I would take half of my shape. I would only take half of them. So I would have these three, I take half of my 6/8. So I had 6/8, and then I only took half of them. So I have 3/8 is what I'm expecting to end up with as my answer. So let's see if we get 3/8 when we try to apply our rule. We want half of 6/8, so half of 6/8. So we know our rule is top by top, bottom by bottom. 1 by 6 all over 2 by 8 gives me 6 all over 16, and there is a common factor of 2 top and bottom. So I end up with 3 out of 8. You could also take out your common factor of 2 as we did down here. So I end up with 3/8 as expected, as I was expecting that I might. So I had 6/8, and then I took half of them. So I only took 3 of the 8ths, because I had 6/8, and then I had this many of them. I had half as many of them. So that's where our argument is coming from. Let's start to apply our rule more generally. So I have 4/3, and then I have 5/4 of them. Or put the other way, because we know multiply order does not matter. So let's use our rule. We're going to have top by top, bottom by bottom, or numerator by numerator, denominator by denominator. And I end up with 20 all over 12. I can see I have a common factor of 4. This time I will write it out the long way. So I have a common factor of 4. So I want to write these fractions in terms of their highest common factor. Be 4 all over 4 and 5 all over 3, which is 1 multiplied by 5 over 3, which is 5 over 3. So we can see that we can write our numbers as factor pairs in terms of their highest common factor, and that allows us to have 4 divided by 4 is 1 and give us a simplified fraction. And 1 times any number is just the number itself, as we know. So let's do our work again. We have top by top, bottom by bottom. And if we can see a common factor or top and bottom before we multiply them out, we can do that too. So I could say that this is, I can see a common factor of 2 top and bottom here. So I could say that this is 7 by 3 by 2 all over 2 by 2 by 5. I have a common factor of 2. So I could write that as 7 by 3 all over 2 by 5 times 2 all over 2. 2 over 2 is 1. So I have 7 by 3 is 21 all over 2 by 5 is 10 times 1, which is 21 all over 10. Then finally, if we get mixed numbers, we know that we never do maths directly with mixed numbers. We are always going to turn these into improper fractions. So I end up with 16 thirds and 10 sevenths. And then I just do top by top, bottom by bottom. And I end up with 16 by 10 over 3 by 7. And I end up with 160 all over 21. And if I can spot to do it, several of these answers, so 3 over 2 could be written as 1.5, 3/8 is just 3/8, 5 over 3 I would be able to write as 1 2/3. 21 all over 10 is 2 1/10. And 160 all over 21 is 7 13/21. So see how many times the number divides in, and then write your remainder as your fraction. So we have 7 plus 13/21. And that is what we need for multiplying fractions. So the rule is fairly straightforward. We have numerator by numerator, denominator by denominator. We don't need to get any common factor. Sorry, we don't need to get any common denominators or anything like that. We are counting up how many of each thing we've got. And that's all we have to worry about for multiplying fractions.